The negation of an implication statement P implies Q is P and not Q. I'm going to, before I do this example, I'm going to show you that this is true using a truth table. Here is the truth table for the implication statement P implies Q. To take the negation of this statement, all we're doing is we're taking the not of P implies Q. When P implies Q is true, not P implies true is going to be false. When it's false, we get true, false, false. So this is the negation of the implication statement P implies Q. Let's see if this statement is equivalent to P and not Q. P would be T, T, F, F. Not Q would be false or F, T, F, T. And joining these two using the word and, T and true and false would be false. True and true is true. False and false is false. False and true is false. If you notice, these two are exactly alike, which means that the two statements are equivalent statements. We will now go on and work on this exercise 2.65. Let n be an integer for which implication is its negation the following. In other words, they're giving us the negation of a statement and they want us to find the original statement, which they say is an implication statement. So let's look at this. If this is the negation of an implication statement, we know that the negation of an implication statement, if you have P implies Q, then the negation of this is equivalent to P and not Q. So let's see. If we let this be P and this would have to be not Q if this is the negation of an implication statement. So we know P represents the integer 3n plus 4 is odd. Q, or not Q, is the integer 5n minus 6 is even. So that means that Q is the statement, the integer 5n minus 6 is odd. So if I want to find the implication statement that this is the negation of, it's going to be P implies Q, and that statement is if the integer 3n plus 4 is odd, then 5n minus 6 is odd.